Okay, turn to page 363. This is section 3.8. And try to figure out what function goes with what graph. And again, remember, if you're not sure, you can always make an XY chart, input, output, and you can pick whatever numbers you want. So like you could shove in 0, 1, 2, 3, what any numbers you want into these formula, and then see how the points would plot. Because remember, these curves are made up of a bunch of points. So try that, see how it goes, and then line them all up, and then we'll chat. Okay, so if you're stuck, x equals 0 is a really good choice. X equals 0, because anything raised to the 0 power, so like 10 to the 0 power is 1, 8 to the 0 power is 1. So right here, if I sub in 0, I get 1/4 to the 0 power. That has to equal 1. And so the only graph that goes through the point 0, 1 is right here. The rest go through other numbers. So this has to be, go with A, right? So double I and A have to go together. Again, notice that this is like 25% to the x power, or 1/4. So whatever I sub in, I keep doing 25% to the first power, which if you go to 1, you get 1/4. So that'd be like this. If I do a squared, I would do 1/4 of 1/4, which is a 16th. So this is what we call exponential decay. It's getting smaller and smaller and smaller and smaller. All right, let's look at this one. Again, anything to the 0 power is 1, so this would be 10 times 1. So where do we have one that goes through 10? That looks like maybe up here. All right, so it looks like B is going to go with 3. And again, notice this is 10 times that. So if I have 3 to the first, when x is 1, I'm already way up there at 30. If x is 2, I'd be at 90. So this is getting big really fast. This is exponential growth. Let's see this one. Anything to 0 power is 1, so that'd be 7 times 1. So which one looks like it goes through 7? And then let's see, this one here looks like it's going to go through 6. So it looks like I goes with C, so I and C go together. This looks like it goes through 7. And again, if I type in 2 to the first power, I'm going to get 14. So at 1, it should be up here at 14. 2 squared is what? 4, and then 40 or 28 would be up way up here. Now this one's decaying. If you see that, anything to 0 power is 1. So 6 times 1 is 6, which is good. But then notice if I have, like to the first power, I'd be taking 1/3 of 6, which is 2. So you can see that it does go through 2. And if this is squared, I'd get order of op 1/9, and I'm going to get a fraction. So this, again, is decaying because it's getting really low. All right, go ahead and look at the questions 2A and B, and then we will chat. I'll pause just for a second. So now some people think exponential are harder than linear. They're actually easier. If you look at the coefficient right here, and right here, and right here, that tells you your starting amount. So and then even here, there's an invisible, let's see, there's an invisible 1 before the multiplier, right? So that's your starting amount. So if you look, you're like, oh, well, the starting amount here is 1. That has to go with this graph. Starting amount is at 10. So that has to go with this graph. Starting amount is at 7. So that has to go with this graph. And starting amount as 6 has to go with this graph. And then how do you know if it's growing or decaying? Well, if the multiplier is above 100%, remember when we did that? So like say 110%, then it's growing. So this multiplier would be like 1.1 in here. And if it's decaying, say by 10%, we would subtract 10% and our multiplier would be 90% or 0.9. So if your multiplier is bigger than 1, which looks like this one is 3, this is 2, those are going to be exponential growth because this is like 300% and 200%. These are decaying because this is 1/4, that's like 25%, and this is 1/3, which is like 33.3 repeating percent. So I can kind of tell how they're going to behave just by going from that. All right, so go ahead and read the next 2 pages. So go ahead and read page 364 and 365, and then we'll pick up there. Okay, so turn the page to the top of page 366, and again, I'm assuming you read those pages. There is a video by the publisher if you want to go to multimedia and look at that. But go ahead and answer 3A and B, and then write what you think those are, and then we'll come right back. Okay, so if things are linear, they're going up by a constant rate. But if they're exponential, they're going up by a percent, or they're doubling or tripling or quadrupling. So, but the nice thing is they always look like y equals. You always have your starting amount here. You always have your multiplier, and it's always exponential. All right. So this first one is, let's see, initial value of 7. That's your starting amount. 10% growth rate. So I'm growing. So that's 110%. So my multiplier is, oopsie, 1.10 without the percent there. And my exponent is going to go right up there. Suppose an exponential function. Okay, I'm starting with 7. And I'm losing 10%, so that's 90%. So that's 0.90 in decimal form. So my multiplier is 0.90. And then again, exponential. So again, linear are always in the form y equals mx plus b if you're going by constant amount, like $10 every month or something like that. If it's a percent, it's going to be exponential, and it's going to look like that formula. All right, so go ahead and try to graph for A and B, and then we'll chat about those, and then we'll keep moving on. Okay, so if you look at this first graph, both of these are exponential. This I know is going to go like this. It's going to be exponential growth because it's 110% as a multiplier. So it's always a good idea to sub in x equals 0 because that's going to give you your starting amount. So 8 times 1.1 to the 0 power, anything to 0 power is 1, so that's just 8. So I know this starts at 8, which again is your starting amount. And then I might sub in x equals 1, which would be 8 times 1.1 to the first power. So that's going to be 8.8, which is going to go right there. And then I could sub in 2, so squared. So on my calculator, let's see what I get here. 8 times 1.1 raised to the second power here. Okay, I get about 9.68. So at 1, I'm at about 8.8. And 2, I'm at, what, about 9.68. And this is going to be curvy, even though I need to go out more. If you want to do negative exponents, like maybe sub in, say, like a -4 into your formula just to see what it's going to be. 8 times 1.1 to the -4. So let's see what kind of answer I'm going to get for that. Okay, I get about 5.5 about. If I can draw it hard on this. But this is going to curve. It's not going to be a straight line because it's definitely not linear. It doesn't fit y equals mx plus b. All right, let's look at the next one. This is going to be decay. Oopsie. And I can tell it's going to be decay because I have a multiplier that's less than 1. So my initial value is 5. If I sub in to the 0 power, I'm going to get 1 times 5. So that's why that guy is always your starting amount. So there's 5. And then again, if you want to sub in some other values. So if I'm going to do to the first power, it's going to take half 1. So it's going to be 2.5. If I sub half squared, it's going to take a half of a half, right? So it's going to go half again. So what would that be? 1.2 something. Right, and again, a half to the third power. And again, you could do those on your calculator if you want. So if you're like, well, I'm not sure what that's going to be, that's fine. It's just going to take a half 3 times, but you could take it raised to the third power and do it that way. And you're going to get 0.6 something, because again, it's going to keep taking half. So again, my line for this, or not line, my curve for this guy is going to be exponential. Now again, it will never cross this x-axis because it'll get infinite close. Like you could do this to the 20th power, and you take half of a half of a half of a half. It's going to get super tiny, but it's not going to equal 0. And again, if you want to sub in like a -1, -2 to kind of get a more precise point, you can there. All right, so let's look at number 5. I think we're going to go ahead and skip A, but why don't you look at number B and C and D are on the next page. All right, so read this. You can skip A, but then go ahead and answer B, C, and D. Okay, so let's look at this one. The download 500 million times already and gains 8 million new customers per month. Okay, so notice that's per month. That is a rate, and it's constant. Like every month it's 8, 8, 8, 8, 8. Granted 8 million, but it's constant. So I have a starting amount, and you can put that first or later. I'm going to put it in y equals mx plus b form. All right, so starting amount, and then we're gaining what? 8 per month. Okay, and you could do something like that. Now, if you wanted to say like downloads and 8 per month plus 500, you could do different variables. But the reality is it's linear because it's going up by 8 per month. That's a rate. That's y equals mx plus b. All right, let's look at the next one. You have 500 starting amount, but now it's 2% each month that it's growing by. So if it's a percent, there's your starting amount. It's exponential. So 500 is your starting amount. Growing by 2%, so 102%, but it has to be in decimal form, is your multiplier. And then your exponent goes up there. And again, you could put m up there for months if you wanted to. Okay, use each model to predict how long it would take to reach 1 billion downloads as the rate stated. So what you could do on y, because it's linear, you could solve an equation. 500 million. So let's see, a billion would be what? Let's see, a billion. Is that a billion? Okay, so there's a million, there's a billion. But this is in terms of millions, so I would have to take off all those zeros. Okay, so I could set my equation equal to 1,000 millions, if that makes sense. That's a billion. So subtract 500 to get your x's all by themselves. 500. Divide by 8, and x equals about 62.5 months. And if I divide that by 12, I could get how many years that would be. Exponential, you can't solve like a linear equation because it's definitely exponential. So that's a problem. We could put it into Excel. We could guess and test. When I teach math for liberal arts, we use logarithms to do this. So that's always an option if you remember logs. But so I could take like 500 and, you know, maybe guess like 20 years. And so 500, 1.02 to the 20th power. Let's see what that gives me. All right, and that gives me 742. All right, so then I'm like, okay, that's not enough. So maybe I want to change this to 30 and try 30. So 500 times 1.02 raised to the 30th power. All right, and I'm getting closer. I'm at 905.7. So I keep guessing until I get that 1,000. And in this case, it's about, I think it's about 35 months. So for exponential, you're just going to have to kind of guess and test. Linear, you can solve an equation to get. But exponential, because the variable's up here, you can't do that. Let's see. All right, let's go ahead and turn the page and look at number 6. Okay, so the next one says, write equations assuming exponential change. Oh, my dog needs out of the room. Okay, just a second. I'm going to pause. I'll be right back. Okay, so obviously these are not linear. They're not doing a constant amount here. So we have to kind of think what's happening. So if I take half of, say, 4, I get 2, half of that's 1. So it's not that. And so when I look at these, I'm kind of like, well, if I divide by 4, if I take a fourth of it all the time, let's see, that would be 1, and a fourth would be that, and a fourth of a fourth would be a 16th. So if I go backwards, I'd be multiplying by 4, which is 16. So remember, this is geometric if it's dealing with multiplication or division, which is exponential. So y equals, my starting amount at 0 is 16. And what am I doing all the time? I am taking a fourth of it all the time. So either divide by 4, but we can't really write that in a formula. So maybe 25% all the time. And this is constant multiplication or division. That is exponential. All right, and this one, it looks like we could try doubling. That's not going to do it, but tripling actually will. So go ahead and multiply by 3 all the time, divide by 3, fill in the chart, and then we'll talk about the formula. Okay, so this one's getting big fast, which kind of indicates its exponential growth. So starting amount is at 6. Multiplier, I'm multiplying by 3 all the time, or 300%, and then again, exponent goes up here. So this one's getting smaller quick, so I know it's exponential decay, so this has to be less than 1. This is getting big fast, so I tried doubling, tripling, quadrupling, whichever one worked. This time it was times 3. And again, it's exponential growth because it's higher than 1. Starting amount here is 6. Starting amount here is 16.